Processing is a programming language designed for creative coding. It is great for beginners who want to learn how programming works, but it's also used a lot by designers who create all kinds of artworks with code. In this video I will explain more of what processing is and why you would want to use it. Then I'll show you all of the important basics, and then we dive straight in to create an interesting piece of generative art together. It'll be fun and easy, and by the end of this video you will know all you need to know to get started with creative coding. My name is Daniel and welcome to this intro to processing. Processing is the name of the programming language, but also the name of the environment in which we write our codes. You'll need the processing software to be able to run the code that we write. And you can download this for free. It's open source and it's available for Windows, Mac and Linux. I'll put a link in the description of this video. So processing is great for making 2D and 3D visuals and animations, and this is also what makes it great for beginners. In other programming languages, your first program might do a few simple calculations, but in processing your first program will draw a rectangle on the screen, and this can be much more intuitive. So the programs that we make are called sketches, and sketches can be super simple, just a few lines like this example that draws 2 ellipses on the screen. But they can also be super complicated and consisting of multiple files that are interlinked all together depending on what we need. But what I find very interesting is that very often with just very few lines of code you can create effects that look very complex, and this is what makes processing so powerful. And now with all this info out of the way, I will show you some of the basics of how to use processing. Let's go. Now if you first open up processing, you see what we call the processing environment, and this is where we write our sketches. If you click the play button, you will run your code. But right now, because we haven't written any code yet, it just shows an empty canvas. And a sketch is a series of commands that we give to the computer. And we call those commands functions. And the first function that I will teach you is the function size. And size is a function that takes 2 arguments, two parameters that we need to input to set the width and the height of our canvas. I'm going to set the width and height to 800 by 800 pixels. And then every line of code we write needs to finish with a semicolon behind it. This can be a little bit annoying, but yeah, it just has to be done all the time, otherwise you'll get an error. Now if I press run, we will see a canvas that is 800 pixels wide and 800 pixels tall. Now the canvas is still empty, so let's draw something on it, and we will draw a rectangle using another function called rect. Oh, without the s, rect. And rect takes 4 arguments, 4 parameters. It's the position on the x-axis, the position on the y-axis, the width and the height that we need to set, and then another semicolon. Let's run this. So there's a coordinate system in processing that has 0, 0 on the top corner, and then on the x-axis I wanted to go 100 pixels to the right, and then on the y-axis I want to go 200 pixels down, and that's the top left corner of our rectangle. And then I gave a width of 300, so that's over here, and then a height of 50 pixels. So this is 300, this is 50, this is 200 and this is 100. That's how we draw on the canvas. Alright, so size and rect are both functions, and maybe we should label them as such, functions. And 2 forward slashes signify a comment. This won't be read by the computer, this is just for us to help ourselves not forget what we're doing. The next building block besides function that's important to programming is called a variable. And those will come in very handy. And a variable, it's like a box. Oh, that's a really bad box. Let me grab my pen. It's like a box that holds, for example, a number, and it has a label, a name, my name, for example. And I can put anything in the box. I can put another number in there, and every time I ask the computer what's in my name, it will tell the number 5. And you'll see in a second why this is very useful. Let's create a variable. I do this with the keyword int, and then my name, and then I say is, that includes, holds 50. Now int is a keyword that signifies that creates a variable, but it creates a very specific variable. It creates an integer, a whole number. So I can only store numbers that are whole in this type of variable. And now that I have the variable my name that contains the number 50, I can use my name to replace, for example, this thing in rect, and say my name. And now if I run the code, it will place the rectangle at 50 pixels from the edge and 200 down, because it replaced the X position with my name. And this can be super useful when you want to reuse a value. For example, I can make a new rectangle that I call rect, and I say my name, my name, my name. It's a bit of an annoying name, my name, but it works. Semicolon. And now we have a second rectangle that will be 50 pixels to the right, 50 down, 50 wide, and 50 tall. And if I now want to modify this, I only need to modify my name and turn it into 350, for example, and suddenly everything has shifted, because now, of course, this is the second rectangle that we draw, and this is the first one, and then the first one has a width, has an X position of 350, and the second one as well, so they're both 350 pixels from the left, but this one has drawn 350 pixels down, 350 wide, 350 tall, etc. So I can really easily manipulate now everything that happens on canvas just by manipulating one number, which is my variable, and that's very useful. Oh, and another thing that's useful is that you can change the variable at different moments. So for example, here if I say my name is my name minus 200, what happens over here is over here my name is 350 minus 200 of course becomes 150, and therefore my name is 150. But because all of our code is being executed from top to bottom, first this rectangle will be drawn, and at this point it's still 350, and only afterwards my name changes to 150, and we get this new rectangle with 150, 150, 150. So let's run that. And there we go, we have a new rectangle that's 150, and this one is still 350 pixels away from the edge as it was written here. Now, you don't always need to create variables yourself. There are some variables that are already built into processing, and those can be very useful. And to show those, I first want to show you a slightly different structure of a sketch that we can use, and this is a slightly more advanced. We're not going to use this in the rest of the tutorial. Let me comment this out to remove it by pressing Ctrl/. And the structure is using a setup and a draw loop. This looks like this: void setup, and then these are special kind of functions that I create that processing calls for me, but don't worry too much about it. I just want to show this because you will see this in many other sketches, so that when you see it, you recognize it. And the way this works is that whenever a sketch is run, everything in setup is only run once. So for example, your size, you only want to set up one time. And then draw is being drawn repeatedly. We can say put a rectangle, rect, and then we use the built-in variables mouse x, comma mouse y, and these are automatically set by processing to the position of your mouse on the canvas. So if I run this, you will see a square of 50 by 50 that follows my mouse, and this draw loop repeats about 60 times per second and tries to keep on drawing the square wherever my mouse is. And the reason you see all the other squares that are not being removed is because nowhere I told the computer to remove the other squares. So every time, every frame, a new square is being drawn under my mouse. So yeah, those are built-in variables, but this construction of the setup and draw, we're not going to use it for the rest of the tutorial, so don't worry about those. Probably my favorite building blocks in programming are loops, and I will show you how to use a while loop. If you already know a little bit of programming, you might want to look into for loops. They are more useful for most purposes, but in this case we will stick to while loops because they are more simple and easier to explain. Let's remove all this again. And the while loop starts like this: while something that we fill in later, and then how do you call these? Parentheses. One to open and one to close the block. And this block is going to repeat until as long as the while condition is something. We create a new variable, int I, and I is just a convention to use as a name when something is used for a loop. Int I is going to be 0. Now we're going to add a condition here. While I is smaller than 10, this thing has to repeat. And then at the beginning here, we're going to write I equals I plus 1. So what's going to happen is every time that this loop runs, I is going to increase by 1. Because if I is 0, then I is 0 plus 1 is 1. If I is 1, I is 1 plus 1 is 2, etc. And then until I reaches 10, because then this is no longer true, I is then not smaller than 10, and then it will end the loop. And I can show you better how this works by using print ln, which stands for print line, parentheses, print line, I'm going to print the value of I, so it's going to print whatever I is. And then whenever you finish, we're going to print line we are done. Alright, I run the script, and now we have looped through this loop invisibly though. It's not happening in the canvas, but it's happening here in the console down below, and this is where all the print statements are. And this is very useful for debugging. If you want to know the value of a variable and you can't figure it out anymore, you might want to print it out so that you can see it. But what we see now, it prints out this number because this print statement is being run 10 times, and then after it's been finished, it jumps out of the loop and prints we are done. So we can also use this loop to draw 10 squares. Let's put the size back in, and actually we can remove all this code because we're no longer using it now. I'm gonna put rect and then hundreds, 200s. Right, and if I now run this, we see only one square, even though it says here that it looped 10 times. And of course they're all placed in exactly the same position, so we can't see the difference. But there's a trick to that. Actually, I'm going to make it a little bit smaller. There's a trick. We can use the number I to create unique positions for all of our rectangles. If I say I times, let's do 80, then the first time this will run I is 0, but then our loop starts and I becomes 1. 1 times 80 is 80, and then the next time this loops, 2 times 80 will be 160, etc. And that is how we get the squares lined up in this line. And I can also change the Y position, of course. Maybe I say I times 5. And there we go. We can now draw lines using I. It will be all in different positions, but it will always remain a line. And what I kind of want is a grid, and for that we need to upgrade our loop. So we are going to put the loop inside of our loop. So it's exactly the same structure as before. Let's say int j, that's again convention, there's no particular reason why you should use that name, but I like to do it, while j is smaller than 10, and then curly brackets, and now this loop I write j equals j plus 1. And then we put the rectangle drawing, we put that in here. Now we want the x position to update every time I is going up, and the y position to update every time j is going up. Let's say also by 80. And maybe also write a print statement, because that will help me explain what's going on. Print, this time without line, because I want it to be all in one line. Print j plus a space, so that we have, it's easy to see. All right. Let me first comment on that space. So now here this print, this puts a space between every time it prints j. So all these lines are the j's, and then also it doesn't skip a line every time when it prints a number. But of course more interesting is the canvas and what has happened. So the first time this runs, so I is 0, I becomes 1, and then it prints out this number 1 that's over here. And then it jumps into here, j is 0, and j becomes 1, 2. And then it prints out the number j that's over here. And then it draws at 80, 80, which is this one. Now this loop repeats, because we are at the end of the loop and j is still lower than 10, so it becomes plus 1 again. And then we print at 80, 160, because now this number is being updated. This number is now 2. And 80, 160 happens to be here, so this is number 2. That goes on, we go to 3, 4, 5 until we reach number 10. And then of course, when j is 10, it skips out of this loop and goes over here. And then also this one is finished, so it goes out. But because I is still smaller than 10, it doesn't continue, it jumps back over here. And then it prints out I again, which is now 2. And then because the position is now updated, now I is 2, so 2 times 80 is 160, which is this corner. So we have number 11, 12, and so on and so forth. And that's how it fills this whole grid. And you can also see it in the console. So it writes these 10 positions of j, and then it writes the next position of I. 10 positions of j, next position of I, until it is done. That's how you create a loop in a loop, and you create a two-dimensional structure with it. So it goes in 2 directions, and grids are super powerful. I like to use them all of the time for all sorts of things. Okay, we are almost ready to start doing something more interesting, but before that there's one more function that I need to show you, and that function is called random. Let me remove this and actually comment all this out. Control/, and then random takes 1 argument, let's say 10, and a semicolon. And actually I want to put this inside a print statement. Print line random. There we go. Now this will print out the value that random, the function random, returns to us. And random returns a number that is between 0 and 9.999999, not 10 included. And if I change it to 5, it will return a number between 0 and 5, of course, or 0 before it, but 99. And every time we run this, it will return a different number. So now it's 2.6, and now it is 1.9. And we can use a random number to set the size of each of our squares differently. So in here we say, instead of 50, we want random 50. And let's also put, that's the width, and let's also put the height of our random 50. And run. Now we should have a grid with all rectangles that are different, that have random width and height. But actually I want it to be all squares, and to do so we need the result of the random to be the same for the width and the height. So I'm going to create a new variable, int, let's say square size is random 50. And then we can use square size and input that here, and we can input that there. And let's see what happens if we run this. We get an error. It doesn't run. And it says here in the console our error. It says cannot convert float to int. Now what you may remember is that when we run random here in the console, we saw that it was not a whole number. It was not an integer as such. And ints can only store whole numbers. So it cannot store the 2 point something something something, for example. And one way to solve this is to round off the number into a whole number. But in our case, we are just going to change the data type that we store into. And we can also use a float, which is short for a floating point number, a number with stuff behind the decimal point. So a float random should work. And because the function rect doesn't care whether you input integers or floats as the arguments, it should still work right now. So if we run this, we only get squares, because every time the value of square size is going to be the same for the width and the height. So now we are going to use all that we have learned and put it together to create an interesting work. And actually we are going to be creating this, and we can do that with mostly the stuff that we've learned so far, but in the process I will also teach some more things about color. And what you see here is again a grid of squares in different sizes. But you see that there's 3 squares actually, so that's the first thing that we're going to make. In every grid there's 3 squares, and we do that just by writing some more squares. We copy this rect, and every loop we want to create more squares, but they have to be at slightly different positions to be seen. So maybe I can add 10 to the x and y coordinates and 20 to the next one. And now we should have 3 squares stacked on top of each other, so they're all 10 pixels apart, because I update the distance plus 10 and plus 20 for the second triangle. Now it's good practice whenever you are repeating a a number to make a variable of it. So this I times 80, we're repeating it over here and over here and over here. So instead of having to type that 3 times, we are going to create an integer, int, let's call it position x, is I times 80. And we can do the same for pos y is j times 80. And then we can insert pos x in here, and in here, and in here. And this of course is being updated still every loop. And pos y, we can do this instead of j times 80. Here, and here, and here. But we also have this distance number, this 10, that's being repeated here, and this 20 that's being repeated here. We can actually create an integer called dist, which is going to be 10. No, actually straight away let's make it into a float and do random 10. So we get a random distance, and we're going to use that over here. And here we do it times 2. So that the third triangle goes a little bit further away. And now we get something that looks slightly different. Everything has remained the same except for the distance that is now partially random. So sometimes they're really close to each other and sometimes they are nearly 10 pixels apart. And the next step for me will be to color those shares, And the next step for me would be to color those squares. So we can color things by using the fill function. Fill will set the fill color, and fill normally takes 3 arguments, one for the red, one for the green, and one for the blue component. And I want it to be all the way red, that is 255 is the highest level it can be, no green, and no blue at all. And if I run this, we will see all red squares. And now I want all squares to be different, so the next square is going to be the same, but green and no red. And the last one is going to be blue. So whatever I set the fill color to, all the next things that you draw will be using that fill colors until another fill color is set, and we reset the fill color after every rectangle. So we will have a different fill color for each rectangle. Let's run this, and we see 3 different colors for the rectangles. But you may have noticed 255 is again a value that we reuse. So maybe we can set a variable for that again. Let's say int color. Now int color becomes color straight away, and this is a way to signify that it's actually a keyword from processing that we can't use because it already means something else. Let's make up our own name. Let's call it col instead. Int col is going to be, well, let's say random 255. And then of course if it's random then it can't be an int, it has to be a float. And then use the col keyword to replace these 255s. And now they should all have random values. Now one other thing that you may have noticed is that over here the background is black. To set the background we only need to do this once, so we don't need to do it in the loop. We go over here and we write background. And background, you can give it 3 arguments just like before. I can give it 10, 20, wait, say 10, 280. Now this creates a color with a lot of green, a little bit of blue and very little red. But if you give it only 1 argument, then it becomes kind of like a grayscale. So 10 is very dark and 255 is white. So this is a bit of shorthand. When I want to create a black background, I just need to type background 0 and it will be a black background. That's what I wanted. And now the last final trick that I want to do is I want to change the blend modes. And blend modes you might notice from layers in Photoshop. They can also have different blend modes. It works exactly the same here. In a normal blend mode, everything that's drawn on top of each other will be, like I said, drawn on top of each other and hide what's underneath. So the blue square hides the green square underneath. But if I change the blend modes, so let's say blend mode to add, that's a type of blend mode, all the different color components will be added to each other. I can show you what it looks like. It looks like this. And the way that it works is because it will take the color that's in the first part, and then the second thing that's being drawn on top will be counted on top of what is already underneath it. So the red component plus 0 is, of course, remains whatever is in here. But then the green component, if you add 0 plus the green component, everything that overlaps now becomes both red and green. And then everything that overlaps with all three becomes both red and green and blue. And of course, if we add red and green and blue together, we get white. So wherever they overlap, they create this white shade. Or where only two overlap, it becomes this yellow or this blue. And that's a really easy way to make an interesting effect by playing with the blend modes. So there we have it. We have created our interesting pattern, and because it is all code and based on numbers, we can easily change some numbers around and to make something else happen. For example, if I change the position times 50 here, then it will become a smaller grid, but I can then change the amount of things that it draws by making it wider again, and therefore it will fill up the space again, like so. Or I can change the size of the squares, like square size is now random 50, maybe I want it to be random 80. And this is a really quick way to experiment with different types of your pattern. And I encourage you to go try and recreate this sketch yourself, and then to play with the parameters, because only through playing you will discover the interesting ways that you can stretch all of this. And also it's really just important to go over all the steps and do them yourselves, because programming is really like a skill, because you have to understand the structure and internalize it. And it's not important to remember all of the codes, because you can just Google those, but the structure, to be able to create your own structures and not just copy those that you see, you need practice and practice. And actually with just a little bit more practice, you can make interesting stuff, like what I did over here. I have a version of the sketch that I added a few sliders to. So let's drag it in. I'm not going to show you exactly how I did this because it takes some more time, but this is done with a library called Control P5. And actually I mostly just copied and pasted example code in here to create these sliders. But now the parameters that are in here, this is the same kind of variables that are in here, I can change them with the sliders if I hadn't hidden them. There we go. So the square size, I can create that, make it larger or smaller, and also the amount of randomness. So no randomness at all is all the same, or a little bit of randomness, or all the randomness. And I can change the grid size. I made a slider for that, super easy. I changed the distance that's between the squares. Now they're all equal, or I can make them all random again. Let's create a grid size. I like it when there's loads of squares. There is I can make the colors more random also, same as with the distance or with the square size. And oh yeah, I've added this stroke feature, but you can't see it right now. If I change the blend mode back to normal and maybe make the border color to white and set the color fill to none, then we can see the stroke size really well. Let's make this a little bit smaller, and stroke becomes thicker or thinner, or it also becomes random. Let's make the square size. And like this, I can create loads of patterns with all the same structure. I hardly modified the code. The only modification that I made is to add more variables that I can control, but the structure is exactly the same as the one that we did, and it offers all these possibilities for all these different types of patterns. And I think that's quite amazing that you can do so much with just so little. I've added one more gimmick in here, the blend modes, and then let's put the color back. Why is it not working? Oh, there we go. So now it's, instead of the blend mode add, it's the blend mode subtract, and this creates a different kind of color. Oh, I was going to say illusion, but it's not really that. And then the last button that I added is the subscribe slider, and it's kind of similar as in real life. If you click the subscribe button, then I get to also do a little dance. Anyway, congratulations, you now know the basics of processing. And if you come across any problems whilst recreating the sketch, then just write a message in the comments and I will try to see if I can help you. But yes, please go and experiment. So if you want to learn more, the first step would be to go to File and Examples. There is a lot of example code that's hidden in here that you can open. Like there's basics, these are all sketches that you can open, and they give information about how to use hue or brightness or forms or data and all kinds of stuff. It's very useful to browse around. You can also copy and paste from these and play with these yourself. And the other thing would be to go to the documentation. If you go to help and then reference, this takes you to the processing website, and there's a list of all the functions that you can use. And it's really not important to memorize the kind of function that exists. It's more important to start to understand the structures that you can use to create this code, like this kind of loop, inside loop structure. That's something that you can only learn to internalize through experience, through building this a few times and trying to create your own ideas. Thank you so much for watching. That's it from me. Now go and play. Which is exactly what I will do with this sketch and try some more things. Let's turn that mode back to, I'll show you the points. Turn that off. I'll stroke one more.